All right, today we get started on our material for the sport course. Today and later on today, we're covering R1. So today we're going to do some prep work for R1. Let's say day one prep for R1. I strongly recommend taking notes while I'm doing it, but I will not only in addition to uploading the video, I do this on paper so I can go scan them right after class, and I upload the scanned notes as well. So if you miss something, you can write down, but writing your own notes is the best way to go. R1 is on equations, so we're gonna prep with distributions and some fraction work. Distributing and fraction. If at any point I'm going too fast, please say something. I try to pace myself accordingly. Normally, if people are writing, you can tell when they're done writing, but so our first example is going to be, we're going to have 5 times 3 parentheses 3 minus 4x. When we have a number outside parentheses, there is an unspoken multiplication going on here. It's 5 times that. So normally, for normal order of operations, oops. Would be parentheses exponents multiply and divide, add and subtract. Subtract. And they go in order. This is step 1. Step 2. These two are step 3 together, and they go left to right. And add and subtract are step 4, and they go together. They go left to right. How you doing, James?
Doing pretty good. Sorry, I can't compare for my class ended.
It's not a problem. Now that's how we normally do it, but that's when we only have numbers. Parentheses, we've got nothing we can do here. I can't combine 3 and the 4x because I don't know what x is. So I can't combine 3 and minus 4x. This order of operation thing, you might have learned some little memory thing to go with it. Please excuse my dear Aunt Sally. But I don't have a dear Aunt Sally. I don't have a Sally in my family at all. I do have the sibling. Please excuse my dumb ass sibling. If you don't have a sibling, you'll have to pick something else. But one of these days, my brother is gonna watch one of these fucking videos and eventually see that I'm referencing you. Hi, Ryan. All right, so we're back to the 5 times 3 minus 4x. Let me pause a second, make sure everyone's caught up with me. And normally we don't put this little dot here, but I'm putting it there for now. You look like you lost a fight with like a fucking tornado or something. Look at that hair. It's all over the fucking place.
That's how it is. That's how I do this.
That started being like a fad, like, I don't know, 5 or 6 years ago. Just the new hairdo look was like just bedhead. I can get the same look getting just waking up and not brushing my hair.
That's exactly what I did. Well, didn't do. Well, I did wake up, didn't brush my
I'm just fucking with you.
hair. I know, yeah, but hey, that's how it is.
That's how it is.
That's how it be sometimes.
Sometimes, fuck yeah, happens with me. Get nice and short, it's a little harder to fuck up. I got my hair cut like fucking 3 hours before class on Tuesday. That way it was fucking nice and fresh. All right. So when we do this, we can't combine these. So what, instead of doing the multiplication with the combined thing, we're just gonna multiply them to each individually. This is 5 times 3 plus 5 times minus 4x. That's effectively what we're doing. So this ends up being 15 minus 20x. As a little reminder, if you multiply, when you multiply two negative numbers, it becomes positive. Surprised you enrolled with the support course. You're just like, really, fuck it, I'm just gonna just dig in the whole way.
2 extra credits. I was like, you know, I'll take that.
It doesn't really add any more work, the grading is based on that. So all it is extra time with the teacher. Some teachers give you more work, but I'm like, sorry, a lot of fucking work. And
I had a support class for my stats class last semester. It was just a normal class.
right,
It was, but like I said, it was 2 extra units, and that's what made me full time. So yeah.
there you go. All right, let's do some more of these. Let's kick it up a little notch. Yeah, this isn't much of a kick up. We're gonna make it -2 times 7x minus 1. Yes. Always let me know when that's not happening, because I can see it over here, but it's outside my peripheral, and that's just out. They're just both conveniently located right outside my peripheral. What I really need to do is, I want to kind of like draw a line right here, but I can't do that. Maybe I'll do, make a little fucking boundary. That way I know where the top is. Big brains on David up here. All right, we're gonna do the same thing again. We're gonna take the -2 and we're gonna distribute it times each thing in the parentheses. And I put a plus there because they're really like added together, but this is the same thing as that. These two are equal. Plus a negative number and minus a number are the same. So here, when we multiply these together, we've got 2 times 7 is 14. There's a minus sign and there's an X. And then we've got 2 times 1 is 2, and 2 negatives make it positive. And this is identical in value to 2 minus 14x. Because addition and, that's not a D, that's a D. Addition and subtraction are commutative. That's the word they use. I'm not going to say it again because they just move around. You can move them around. That's what commute means. You move to work. Commute to work, you're moving to work. Is it 2 units? It should be easy to A.
Yeah. I think you'll be all right.
Everyone ready for the next? All right, let's go big or go home. Let's do a bunch of shit. Oops. I don't want to put the 5 in there. I'm going to just have it like this. We're going to do each one separately. When I have minus in front of something but no number, the minus still has to go through. So there's like an invisible 1 here. So we're going to have minus 1 times 5x minus 1 times -4. And then minus 1 times 7x minus 1 times 1. Now that line, hopefully within a couple weeks, is a skippable line for you, and you will go at least to the next line. You should probably go to the next line, but not past it. Actually multiplying those out. And trying to keep the colors consistent with what the stuff is on the line for. So frequently you can go from here to here. Because let's face it, otherwise you have to write it faster, guys, right? You could skip this line, but it's easy to fuck up shit when you do. Because then you got to do a lot of it in your head and keep track of a lot of it in your head. The next step is the following. These both have, all of these have an X with numbers in front of it. These are called like terms. Same variable, same exponent on them. When we just have an X, it's the same as X to the first power. That's how we list exponents up above. And the -3, the 4, and -1 are like terms. Each of these little individual things is called a term. Terms are separated by addition and subtraction. So we can combine like terms. And I'm going to write out what is really going on with a skippable step in the future. We have the first set of like terms are 6x minus 5x minus 7x. This is like doing 6 minus 5 minus 7 times x. Here I factored out the x. That's what this process is called. Factor out the x. And then we do order of operations on what's inside the parentheses. 6 minus 5 is 1. 1 minus 7 is -6. So this all condenses down to -6x. This is probably what I would do, and I would not write this thing on the right, but it is what's going on. And we do the same thing with the -3, 4, and the -1, but there's nothing to factor out. We're just gonna add that shit together. And that adds up to 0. So this just ends up being the -6x because all of the numbers added to 0. Oh, I'm off screen a little bit. Is that not super fun? This is not the most, mind-blowing thing you've seen all day. Everyone ready for more? Let me give you guys one to work on for a few minutes and then we'll do it together. We'll pick it up a notch and have 2 sets of parentheses. One inside the other. There we go. And to guide you on your way, you probably want to distribute the inner grouping symbols first. There we go. What? I know who we had for stats last semester. She emailed me about him.
I had her.
She could teach it.
She was really good at it. I really liked it.
Cool. Never actually asked students about her. I've talked to her a lot of times. I like Danielle.
No, like the way that she teaches, it was like you could not possibly miss like what she was trying to explain. You know what I mean? It was really good.
She make you guys use tables or
It was like what,
like the Z table? That,
oh yeah, we used the Z chart, the
Yeah.
T chart, the chi-square chart.
ah,
It was really cool though. I'm like a statistics kind of nerd, so I really,
there's a lot of apps nowadays that do it.
yeah.
It's a lot easier.
Yeah,
Those charts are a bitch to read.
definitely can be sometimes, but I did pretty well.
As soon as you haven't read the chart for like one of those charts for like 3 weeks, you're like, which one do I choose when I'm going? It's between them.
Yeah.
It gets fuzzy
For sure.
because you don't do it enough.
It was cool though.
Said no more light for you. No, they're like, there's no one in here because we're not moving. I wonder where the motion sensor is in here. I wonder if I had a little laser pointer and I pointed a laser at it, if it would trigger it.
You distribute the parentheses inside the bracket first.
Yeah,
Okay, so you do 5 times parentheses first, correct?
yeah.
Okay.
All right. So doing that, I'm actually gonna leave the bracket here for that part. And do this shit in red. This is what I was talking about. We have minus 5x and then minus 5. And we still have the 4 times 2x plus 1. Now you could have done this at the same time, but I wanted, this is what I was saying to do first. So I just did it first. You could choose to combine this first. 2 minus 5 is -3. Which is probably technically the correct way to do it. Or you could either distribute the 3 to the 2 and the 3 to the -5 and add them up later on. Gonna have to add them eventually. Now we distribute again. 3 times -3 is -9. 3 times -5x is -15x. 4 times 2x is 8x. And 4 times 1 is 4. Put them together, we will put those two together. -15 plus 8 is -7x. And -9 plus 4 is -5. They often call doing this where you're combining the steps, they call this simplifying. So if you see them say simplifying somewhere, this is one of the examples of where they use simplify. No problem. Hi.
I emailed you earlier.
Okay.
Wanted to add the class.
Yeah,
you know, I just don't have time today, so. Yeah, next week, I'll be here.
Cool.
Right.
Have a good one. All right. You guys good with that? Does that all make sense? All right, fucking dreaded shit. Fractions. We'll start off with something simple. 5/6 plus 1/6. The numbers on top are called numerators. And the numbers on bottom are called, and I fuck up spelling this all the time, denominators. I usually write so fast I write demonators. Demon rather than denom. I very rarely use the word numerator and denominator because everybody knows what top and bottom are. Those are easy words to remember, and I'm not some anal math teacher. Sometimes we'll have words that there's really no other easy word to use, and I gotta stick with math jargon, but when I can avoid it, I do. When we add, subtract fractions, the bottom has to be the same. Must be identical. As they are here. When they are, this is equivalent to having one single denominator that's the same and putting 5 plus 1 on top. And we add the 5 plus 1 and we get 6. This is equivalent to 6 divided by 6. So fractions mean division. And 6 divided by 6 is 1. Going from here to here is called simplifying as well. There is another way to do this without doing division. Another way to simplify is to write things that multiply together to make the number. 6 is the equivalent of 2 times 3. And the same on top and bottom. You'll notice I use the dot for multiply. I didn't say this earlier. This is a common thing after algebra because we save X for variables. As you've seen, we've been using X for variables. Now, usually these two aren't the same top and bottom. They're usually different, but you can write these. This is called factoring the number. As 2 and 3 are called factors of 6. Factors is the word for things that multiply together. Okay, the idea is once you factor, anything that appears on top and bottom of the same fraction, you can cross off and replace with a 1. It's worth noting to replace with a 1. A lot of times, teachers and students skip that. It is technically what's happening now. 3 and 3 go down to 1. Because like in this case, if you don't write the 1, you just cross everything out. I've seen oftentimes students will write 0 because there's nothing left on top. But it's not 0, there's 1s. This is 1 times 1 over 1 times 1. 1 over 1 is 1. That's the idea of factoring. That's the simplest form of doing adding and subtracting fractions. No one's still writing. Awesome. Go on. When the bottoms are different. Damn it. I took off my post-it note, which was showing me right where I could go up to. We have to find a common denominator. And that is one of the few instances where I am not going to say bottom. It's a term, common denominator. They say it all the time. So let's set up an example and I use it to motivate the idea. We're gonna have 5 over 4 minus 3 over 2 plus 7 over 8. One way of finding the common denominator, I'm going to do this over here on the right. You may like it, you may not. What I'm going to do is I'm going to write each of the denominators down. And then I put a little colon to show like this is a column over here. And then I'm going to write the factors of each number. I'll start with the first number. 4 is 2 times 2. Two is just 2 times 1. We don't need to put the 1, but I'm going to line up the 2 with another 2 from above. If a number exists in the row above it, right underneath it. 8 is 2 times 4, which is 2 times 2 times 2. So the LCD, least common denominator or lowest common denominator, it's called the LCD. Pull 1 from each column. This is 8. Okay, so I know I'm going to do a bunch of shit to that 5 over 4. And then I'm going to have minus 3 over 2 plus 7 over 8. When all is said and done, I'm going to have an 8 on bottom. One way I need to get these numbers to equal that 8, we got to figure out what multiplies by 4 to get to 8. If you do the table, is actually the hole in the graph. The missing number here is a 2. So I'm going to multiply this bottom by 2. And if you multiply the bottom by 2, you got to multiply the top by 2. We do the 2 over 2 because that equals 1. And when you multiply by 1, it doesn't change the value. And I'm gonna have 2 times 5 for that first term right there. This one is missing 2 times 2, which is 4. So I'm gonna multiply this by 4/4. 2 times 4 is 8, 2 times 4 is 8, that's all good. Here I've got -3 times 4. Kind of want to draw the dot in between them a little high, otherwise it looks like a decimal. That's the one real drawback to using the dot. And 8 already has the right denominator, so what we're going to do is we're just going to add this up. Okay, everyone with me? Wait for Ricardo. Richard. Richard, it's Richard. It's Ricardo?
Yeah.
Fuck.
I was thinking about it.
Yeah, we got him. Now, this table over here is a skippable thing, but like if I'm doing a bunch of fractions and the denominators look ugly, I will actually still do it. Because it is help. It does help, makes it easy to track everything. Now we can deal with the stuff on the top. 2 times 5 is 10. And we have -3 times 4, which is 12. Plus 7. Still divided by 8. And we combine those together and we have 5/8. At this point, check to see if that simplifies. Five is just 5 and 8 is 2 times 2 times 2. Notice you don't need to refactor it out when you're checking for simplifying. You already have factors of the bottom already. So you just need to factor the top. Nothing cancels out there. So 5/8 is the final answer there.
One of the decimals on the top.
No. Believe it or not, decimals are the hardest thing to fucking work with.
So.
Yeah.
Why?
Because then doing steps later on, if you have to work with other things with it. 5/8 is 0.625, which isn't too bad. It's only 3 decimals. Sometimes it's 4 or 5 decimals. Sometimes it's fucking 6 decimals. Now, if you're adding it to other ones, it's a pain in the ass. Whereas just adding 2 fractions together can be pretty easy. Now, granted, if you're going into engineering, probably going to want it as a decimal. But you can always do that at the end if you want to convert this to a decimal. That's worth noting right here. I'll put optional. You do 5 divided by 8. I'm not gonna go over how to do division longhand. This is 0.625. And if you do it, you should probably put the 0 in front if there's no number. That way it's obvious it's a decimal and not just a dot that was the pin just hit the paper. All right, let's kick it up. Probably only got time for one more. Let's do 5/6 plus 3/8 minus 1/12. Why don't you guys try to do it real quick? I'll give you guys like 4 or 5 minutes and then we'll rush through it together. Just so you know, when you're going the right way, the LCD should be 24 if you've done it correctly. But find that on your own. Give you one more minute. Give you longer, but we don't have too many minutes left. All right, if we go through and we factor these, 6 is 2 times 3. 8 is 2 times 4, which is 2. And then 4 is 2 times 2. I don't have another column for 2, so I'm going to make another column for 2s real quick. And 12 is 3 times 4. So I got a 3, and then 4 is 2 times 2. I got 2 columns for 2s already. I'll put them in there. We take 1 from each column. I've got 2 times 3 times 2 times 2. This is 6, 4. 6 times 4 is 24. Jimmy!
We still holding this in the same spot?
Yeah.
Alright,
All right, so the 6. Good problem. 6 is missing the 2 times 2, which is 4. So I'm going to multiply that fraction by 4 over 4. And of course, 6 times 4 is 24, so that checks. We've got 5 times 4 on top. Eight is missing a 2, so I'll multiply this by 2 times 2. It's missing a 3. That's not right. I saw right away because 8 times 2 is 16, and it did not give me the 24. That's a good way to check. Make sure these still multiply to the bottom. 8 times 2 did not. All right, this is plus 3 times 3. That was going to be a fuck up. And this is just missing a 2. And I've got the minus there. Don't forget the minus sign. That was one click on the brightness and it just went way down. So, all right. So we start multiplying. I got 5 times 4 is 20. 3 times 3 is 9. Minus 2. It's still over 24. This is 29 minus 2 is 27. The bottom is 24. Then we check to see if it simplifies. The bottom, you don't have to reinvent the wheel. You already have the factor. Just bring that down and write it down. You've done the table. 27 is 9 times 3. And 9 is 3 times 3. So the top is 3 times 3 times 3. Doing this is called a prime factorization tree. All right, so we do have something that cancels. I've got a 3 here and a 3 here. We're gonna cross them off, replace them with ones. Now, we already crossed off the 3 on the bottom, so I can't cross off another 3. They only go off in pairs. So we're stuck with 3 times 3 on top, which is 9. The bottom is 2 times 2 times 2, which is 8. So our answer is 9/8. I'm frequently fine if you leave it like that. I don't know if the homework's gonna demand you to do something different. So they may ask you to write it as a mixed number. What you want to do is see how many times does 8 go into 9. And it goes in 1 time. So I can write this as 8/8 plus 1/8. The 8/8 is 1. And generally, we don't put the plus sign between them. This is called the mixed number. And the name for this is improper fraction. Where a proper fraction just has a smaller number on top rather than the bigger number on top. And that's it. We got a good 7-minute break till next class. I ran a couple minutes over. You can stop record.